this groove feature, it isn't straight in the casting. It's not. It's slightly that way. So when I go about squaring this up, I'm going to square it up to that feature, because I've got to get that out to 12.5mm to take the bottom of the damper. But I don't want to go taking these edges off and then find that I've not got enough material to take full cuts inside here. So it's a flat surface on the bottom. This corner here is actually the squarest, but I'm going to ignore all of that and square this up on this groove here. It's fairly flat inside. I might have to clean that up a little bit to clamp a parallel in there to reference it on the parallel. These angles are all over the place. They're not the same. There's no spec on the drawing for what the angles need to be, so I might take a cut of that and actually clean that up. Just not liking the asymmetry of it. Not a very good casting, that bit. So this piece has just been lined up with like a 10mm stud resting in that groove, and then lining this up by eye with the table grooves. I'm going to come down, take this face off. That will give me one reference face. Flip it around, dial that reference face in to be parallel there, take another face off, and then I'll probably think about taking this out and putting the vise back on and holding it in the vise from then on. Still don't know what I'm going to do with these angled tops here. Nightmare. Yep, that'll do. Flip it over. So with this part turned around, that back face is machined flat and it's dialed in square to the table. Make that surface flat, and then I'll have two parallel ends. Whoops, put that off. A bit on the wrong angle there. Haven't gone too deep, it hasn't even cleaned it all off. Go. Lovely clean. Let's just make sure I haven't made it shorter than I wanted it to be. It's 61. I think I worked it out at 57, something like that. That's been put in. That's been squared up the square. Right, flat enough for measurements and references. These angles on this block, on one side is like 19.8 degrees, the other side is 17.5 degrees, so I've got a 20 angle block here, so I'm going to make it 20 degrees. There's no reason why the angle makes any difference, I just want it to look the same. So I've marked a centre line in here and a limit line of how thick this part needs to be. I just need to clean it up evenly to the centre line on both sides. So I'll have to do, I think, this side first. Taking off that surface until it reaches that centre line, then flip it over, come across and do the other side. Really can't bear pieces that don't look symmetrical. It makes you think that they're not symmetrical for a reason, but it isn't. It's just the way it is. So here's a 20-degree angle block under the part. Take this face off to 20 degrees until I just clear that centre line, which is above the height that I need this piece to be in the end anyway, so I can always come back and adjust the height if I need to. Alright, so I've got a nicely centred up angled part there. It's not exactly centred, it's longer on one end than the other, but the angles look the same, and I need to take all the material off this end to get it to the right length. That's not going to be hard to do. So I've had to work out how to compensate for this pivot being off centre. It's actually 1mm off centre, which doesn't surprise me. That's the error that I made in the travel. So that part there would be nominally 19mm thick, so I'm going to make it 20mm thick, and then I can put this in the correct offset, and it will bring all the other dimensions of all the other parts back to normal. So the compensation is going to be in this slot here, to take account for that being a mistake. I'm probably going to have to take this apex down, not by taking material off the bottom, but by taking off chamfers, angles off of these two planes here. So I'll mark it down to a mark out line and bring it down that way, rather than mess about trying to redimension everything. The next feature is going to be a hole going through the centre of this, but it calls for a through hole. I'm going to try and make it a blind hole on this end so that you don't see any hole or hardware sticking through. It'll also make a better lock up for the threaded pin that needs to go in there. There is a pin that goes in there, but it's expected to just bind up on the threads as the threads run out. That's not a very good location for anything. Here's a 6mm tap. It's going to pass straight through this top hole, and it's going to cut the thread in the lower blind hole. So I don't want to bottom out in the bottom of that blind hole, so bring this down here, set that to 0, and I definitely won't take it in more than 10mm. Then I'll bring it out again. I'll finish it off and bottom it out with a bottoming tap by hand once I get it out the vise. A bit of squirt on it. And that should do. That has at least started to thread off. I'll finish it by hand, so that I don't break taps or strip threads by bottoming out. So, clearance hole here, 6mm threaded hole in there, not coming through to the other side. Right, so I've got little cross markings there. I've basically got to put this back in the mill and bring these two tops down to get rid of those marks. And that will bring the apex of this piece close to that 6mm hole and allow the cylinder enough clearance to pivot in it. Currently this is far too high to accept the pivot that goes in the top there. It will bind up. Last two features were some holes in the side here that are going to take that vertical plate that's going to guide the damper down. So I just turned up a little pin, threaded one end, slotted the other. That pin is going to screw into that blind hole and act as the pivot for the bottom of the cylinder. So that goes in there, and it bottoms out in the blind hole in the bottom there. So there's a good retention. There's no reason for that to come undone. This doesn't have to be particularly free in the way that it works. It's nice and snug and tight. It's only going to move through a very small arc as it comes down. But as it sits on the base, there should be no hardware showing as such. That piece should be finished. Very good. So this has now got one right angle on it there. I'll take it out, deburr it, clean it, glue it up, and then start marking out some lines. I've just done a double check on this shape here, and I'd made a very serious error. I had put this radius on this hole here, but this hole is offset 3mm from the centre. This is actually the centre line, 3mm across, so blued over those error lines again. Centre popped another mark in the proper position, put the radius in and remarked these lines. That would have ended up looking very, very sorry if I hadn't noticed it. Always do the double checks. Alright, pay attention. What I've got here is I've got to align those two 6mm holes so that I can connect them with a long slot. So I have two 6mm pins, upside down end mills, placed into those holes, and then a parallel pulled up against the pins and held there with magnets, and then I can dial in on that parallel, and that will get the work parallel with the table with regard to the two 6mm holes. So I have table stops set here and here. This is just hovering just off of the first hole. I'll come down and touch off, and then backwards and forwards, taking tiny ginger cuts to get that groove out. It's a 4-flute thread mill. A 4-flute end mill. I didn't want to use a 4-flute, but it's longer than the 2-flute, so I'll just take tiny cuts, and hopefully there's not much chatter. There is this little latch part of this slot. I'm not going to bother milling that out. It's only a tiny little nub, and it's such horrible stuff to mill anyway. It's got burrs and ragged cuts all over it. It's rolled flat steel, so what can you expect? Horrible bit of metal. Okay, that's about as clean as that's going to get. These are how these two pieces go together. Now, I've deliberately not countersunk these two holes. Countersunk screws tend to have very, very tiny socket heads on them, and you can't get them tightened up that tight, and if you try, you just strip them out. So I don't like socket heads at the best of times, but stay away from the countersunk ones if you can. So with that centre drill in the end of that bar, which is in the centre of the bar, using a dead centre in the hole, which also has its own centre hole, which is in another centre, all you got to do is to set the chuck so that this round surface is centred up, which means that that bar will be centred up. It's a bit of faffing around having to drill the hole first, but it makes the setup a lot easier. And then when I finish this piece and part that off, I'll make sure that I drill another centre hole in the next part so that I can go through the same procedure again without having to mess in the chuck. So just a matter of trying to set this up. I'm not going to try and grab that, it's got sharp edges on it. So as promised, I just need a new centre hole in the remains of that stock, and that will allow me to re-centre this when I take it out and put it back in again. So that's enough to do the old trick with an extra dead centre stuck in that hole, and then centre the square stock up on the round dead centre. So this needs just a small undercut just to relieve the thread that's going to go on that stub. Yeah, I'm going to leave it at that because otherwise it's getting too thin. And an M6 thread on there. There we go. I will countersink these holes and run the tap through again. I don't normally do it on the mill because it's too much faff. Also going to put it back in the lathe and round off that end. It's looking a bit brutal as it is, but yeah, not too bad. So here is a little nut. It's just a piece of hex been turned down with a little spacer type spigot on there. This goes into this linkage. That part is going to carry the screw that's going to activate the switch. Screw goes through there. That spacer on the end there needs to be a free run in that slot. And it will tighten up and jam up on that that spaced area. So as the saw works its way down, the screw that's going to be in there is going to work its way towards the switch. It'll switch itself off, and when you want to lift the saw up, it'll latch in that position there to park itself. That's the idea. So it's pleasing that this does actually latch itself. It doesn't jam or snag up. Well, that didn't work. So it's got to have some degree of swing on it. It'll get looser over time as well. So that part of the linkage moved along. This is the linkage and the damper. All the parts are finished. This damper hasn't been soldered together yet, and I haven't soldered up the needle valve adjustment at the top. But what I would do next is to position this block to make sure that the linkage comes up and down freely. It kind of almost does. This comes right the way down to the bottom. That is the screw that's going to switch the device off when it reaches the bottom. Be a little rocker switch under here, and when you want to lift it and park it, that linkage falls into that slot quite nicely. So it falls all on its own, doesn't require any persuading to go in or anything like that. So that's how it will be in its parked position. What I'll do next, I'll take these pivoting screws out and I'll bolt everything together tightly so that it's all lined up as it wants to be. Then I'll mark out the position of this bottom block with some scribe lines around the edges. Measure in as to where I'll put the blind holes underneath this block, drill the holes up or drill the holes down, come up from underneath, whatever. Put some studs in the bottom of this block, and then that can be secured down to the base plate, and that will be that done. Bit of binding in it. That's mostly coming from this cylinder. That's got to wear in. Wanting to get that nice and snug rather than too sloppy. The other point to think about is I want to really get that as close to that motor as it can go, because that's the most effective use of the damper. If you put it right out here, the damper becomes ineffective because it's at too much of an angle. But close up, so that you can get close to that motor when it's parked, that'll be the best position for it. It'll also give me more room to get material through that's actually going to be cut when the vise is in place. Glad I've got all these parts out of the way, because the temptation would have been to put the frame on, put the blade on, and then the whole thing works. And you know, this would have been a bit tedious to do after the event of getting it working. Get all the boring stuff done first before you finish it off.